Okay, this is an opportunity to learn a lesson that you will legitimately use all the time in other classes, mainly science. Chemistry, physics uses scientific notation all the time. So, scientific notation has two distinct parts. You have the base and you have the exponent. And what this number legitimately means is 2.3 times 10 to the third. And I know that we want to put a dot here, and you can, but scientific notation will almost always use an X because it's a science concept and not a math one. What this means is 2.3 times 10 to the third is 2.3 times 10 cubed, which is 1,000. And then you would just multiply that number through. But the benefit of scientific notation is it allows us to do this process very quickly. We take 2.3, and since this is a positive exponent, we will go to the right 3 times. 1, 2, 3, and the decimal now goes there, and we insert zeros. So this number is 2,300. 2.3 times 10 to the third is the same as 2,300. And the reason why we write those is scientific notation allows us to write massive numbers without having to write hundreds or thousands of zeros. We can write them always in this format. So, we're dealing with these numbers. Now, this is for candy. Positive exponents go to the right. Negative exponents go to the left. You tell me that tomorrow in class, you will get a piece of candy. Since we are dealing with a positive exponent up here on the top, we would go 2.83, and we're going to move it 3 to the right. 1, 2, 3. Decimal goes there. We add the 0, and so this is 2,830. Now down here, we have a negative exponent, so we're going to move it left. So we go 1, 2, 3, 4. The decimal point goes there. And we get 0.000422. This one, negative exponent, so we go left. So we get 8.3, and we're going to go left 5. 1, 2, 3, 4, 5. We add zeros. 1, 2, 3, 4 zeros. 0.000083. Okay? It's important to actually count it out and not say we're just going to add 4 zeros because we actually don't. It's important to count each direction. Okay, so that's going from scientific to regular notation. So I want you to try these on your own and see how they go. This becomes 4, 2, 3 with 4 zeros. So 4,230,000. This becomes 0.001002. And the bottom one becomes 1, 2, 3, and 6 zeros. And this is the main reason why scientific notation is better to write in this type of problem, because this number is massive and hard to read, where this number is easy to say. Okay, so that's scientific notation to regular notation. Now, going the opposite direction, in scientific notation, a key rule is you can only have one number in front of the decimal place. So you can't have 12.3, you would have to go 1.23. So in this example, we have to put our decimal point here, and so we go 3.4, we don't need to add the zeros, times 10, and we have to say to ourselves, is 34,000 a big number or a small number? Well, it's a big number, so we have to move the decimal point to the right. 1, 2, 3, 4. So it's 3.4 times 10 to the positive fourth. Now this one here, we once again, one number in front of the decimal place, so we put it here, and we're going to move it 4 this direction. 1, 2, 3, 4. But since our original number was very small, we are going to do a negative exponent, and we moved it 4 to the left. Finally, the last one, the decimal point has to go here, and we'll put a 0, so it's 1.0, makes it easier to read, times 10, Now this is a small number, so it's a negative exponent, and we moved it 1, 2, 3, 4, 5, 6 left. So it's 1.0 times 10 to the negative 6. Try these on your own and see how they go. Top one should be 1.8 times 10 to the 6. This should be 2.45 times 10 to the negative 1, 2, 3, 4, 5. And the last one should be 1.0 times 10 to the negative 1, 2, 3. There we go. How are we doing on time? A little long, but we have one more concept to cover. If we have numbers multiplied together, what happens here is that we can do a shortcut in order to solve these. Now, the other flip side is you could just change these to regular numbers and use a calculator. That's acceptable, but it would take a lot longer than what we're hoping to do, which would be if we just multiply these two numbers, 1.4 times 7.6, which I can do over here, 24, 84, so 10.64, and we add the exponents, because that's what we learned last time. We have 10.64 times 10 to the 7th, but in this case, since we have to move our decimal to this, it would be 1.064 times 10 to the 8th. Okay. Now this can get a little confusing. Got to be kind of careful with these when you're changing from this to this. But what I normally do is I'll just change this into a regular number like this, and then go to there. And that's fine. Now this is probably a bad example of the shortcut because it's a little bit trickier. This bottom one might be a better example because 1.2 divided by 4.8 is just 1/4 or 0.25 times 10, and -1 minus negative, that should be a -4, minus a -4 turns into 3. So that becomes 250, or 2.5 times 10 to the 2nd. Once again, if you wanted to just multiply these out the long way, you could, but the shortcut's beneficial sometimes. This one, we're going to distribute the exponent into both of these. 4 cubed is 64 times 10 to the negative 6, because we multiplied. So then decimals there, so our regular number is 0.00064, or 6.4 times 10 to the negative 5th. Now I know I went a little quick through this section, and that's for two reasons. Number one, I feel like you just need examples. So ask me for help on these individual ones, but I want you to at least have seen what I'm doing, which is just multiplying the regular numbers and then using our exponent shortcuts. But it just takes practice. So make sure you ask me on those. Okay? We are not going to do those because the video is running long. So make sure you ask me for help. There's a couple IXL sections, and then we will take our time to make sure we understand this concept, and then there's a quiz after that.